Hello, my name is Brian Tu, and I'm joined by Karanveer Singh and Daniel Dreswicki. Today, we'll be discussing our final project, WebTime seam carving, using C++ and WebAssembly. Web pages today are now accessible by a wide variety of devices. Because of this, images need to be adjusted to different aspect ratios as well as resolutions in order to fit on the screen. Our project aims to change the size of an image dynamically in order to fit it on the target device. In order to achieve this, we need to be able to perform the seam carving calculations very quickly. We will implement a fast seam carving algorithm in a low-level language like C++, perhaps using some parallelization. Then we'll use a WebAssembly tool to convert the code to JavaScript and use the code on a website as a proof of concept. Seam carving is a technique used to remove pixels from an image without removing too much information. The idea is to find areas with low energy or importance within the image and remove them accordingly. You'll see examples of this in the following slides.
Here's an example image we use of Thanos. On the left is an energy map using the gradients in the X direction, and on the right is an energy map using the gradients in the Y direction. Here are examples of the seams that are generated using the energy maps from the last slide. Here are the final images resized in their respective dimensions.
Single instruction, multiple data. Portions of the code can be parallelized by having multiple threads working on them simultaneously. The most time-consuming step is the shifting of pixels once the seam is removed. We tried to use PostXP threads in order to multi-thread this process. However, this ended up being slower because the process is memory-bound rather than compute-bound, and we are bottlenecked by memory access. WebAssembly. A WebAssembly can be used to compile C++ code into JavaScript code. We attempted to compile our C++ code with mscripten, which is a trans compiler that can compile C++ into JavaScript. However, this was unsuccessful as the resulting JavaScript file had errors with OpenCV functions. Our solution was to instead compile OpenCV into JavaScript, and this was successful, and now we were able to use OpenCV functions in JavaScript, which we consider an absolute win. So our JavaScript implementation, we utilized the new OpenCV.js to implement the same algorithm as the C++. Obstacles, however, were no pointers in JavaScript, lack of documentation, and functions that work in C++ but don't work in JavaScript. After overcoming these obstacles, however, we were finally able to implement with relative success, and we successfully resized images.
Here's an implementation of the algorithm that we didn't end up using, but it was basically a port of the C++ code built in C#, and wrapped around that was a .NET web application that called all of the functions from the port.
Here's a slide that shows results from running the C++ and JavaScript implementations on two different images. As you can see, it's pretty clear that the C++ is hundreds of times faster than the JavaScript implementation. If we had more time, we would like to figure out how to compile the entire C++ implementation into JavaScript, not just OpenCV. We would have liked to have made a nicer web interface. We would have liked to be able to optimize the code and figure out where we can parallelize. And lastly, be able to remove vertical and horizontal seams in the same run. And now to conclude our presentation, we've included clips of a few demonstrations. Here we want to demonstrate our C++ implementation by removing 150 vertical seams from this test image. So as you can see, it ran in a little over 300 milliseconds, and the resized image is significantly smaller than the original. Here we want to demonstrate the JavaScript web implementation on the same image, and we will subtract the width of this image by 50 pixels. In order to save time, we'll return when this is complete. So here the image is finished processing, and it took a very long time, 25 seconds to complete. And as you can see, there are artifacts in this image, and that is because of the lack of 64-bit floating point capabilities in the JavaScript OpenCV.